In this video, I am going to discuss about the Sandmeyer reaction. First of all, you take the RB flask. We need to take the equivalent weight of sodium nitrate and HCl. So both are react to each other's. Then it will be form the nitrous acid. So what is the nitrous acid? Nitrous acid formula, it's a HNO2. So nitric acid formula, it is a HNO3. Don't confuse with that. So here I have the HCl. The HCl, it can dissociate in the form of what? H plus and a Cl minus. What about the sodium nitrate? The sodium nitrate, I have the NaNO2, that will be dissociate in the form of Na plus and a NO2 minus. So now what will happen? I take the H plus and NO2 plus, NO2 minus. So that will be combined to form the nitrous acid of HNO2. The what is the least out structure of the nitrous acid? It is a OH and a N double bond O. So this is the structure of nitrous acid. So once you get the nitrous acid, you will add the aniline derivative. Okay, so this particular aniline, it's reacted with the nitrous acid. Okay, in the color appear the reddish orange precipitate. So it indicates that the formation of what? A formation of diazonium salt. So diazonium salt, it's the most important derivative in order to make the alkyl halide derivative. So it is a arene halide derivative. So alkyl halide derivative we can easy to make with that aqueous base because it is a sp3 hybridization. But if you want to make the haloarene derivative means the benzene ring with the sp2 hybridization, I need to attach with the halogen derivative. For example, fluorobenzene, chlorobenzene, bromobenzene, iodobenzene. So for this haloarene derivatives, I need to make the diazonium salt. It is a preferable method. So now I got the diazonium salt derivative. So from the diazonium salt derivative, I need to add the cuprous chloride. Now what will happen? I got the corresponding alkyl chloride I am going to get. So if I take the diazonium salt treated with the potassium iodide, I got the alkyl iodide, and copper cyanide means I got the cyanobenzene. Okay, if it is R groups or benzene ring, corresponding benzene derivatives are there. So here in this case, I am going to get the bromobenzene, or here cyanobenzene and iodobenzene and so on. So now what is the reaction? In this reaction, the aniline is treated with the sodium nitrate in presence of HCl. So as you know very well, the both sodium nitrate and HCl is going to be react. It will be form the nitrous acid. So HNO2 is going to be formed that. Okay. So now what will happen? In the HNO2, it's react with the aniline derivative to form the diazonium salt. That diazonium salt again it's reacted with the cuprous chloride. So what will happen? So again the diazonium salt react with the cuprous chloride. I will got the alkyl chloride. So now in this derivative, instead of this R group, in this R group I have the benzene ring. So definitely I can expect that it's a chlorobenzene. What about this one? The byproduct of the N2 gas will be liberated outside. So now in this mechanism, I just explained about that. How can you can you convert into aniline into chlorobenzene? So now NaCl, it's treated with the HCl, NaNO2 treated with the HCl, you will got the nitrous acid. So that particular nitrous acid is going to react with the aniline derivative. So now here in this case, the elimination of water molecule is possible. So once you condense the water molecule, what you will get? You will get the unstable intermediate of this intermediate. So once you react with the HCl, okay, the oxygenated, the negative charge obstruct the proton charge. Now I got that this type of conjugated intermediate. So once you this lone pair is shifted towards this nitrogen, now what will happen? The OH group, it's leaving as a eliminated one. So now you got that cation property. That cation of the N2 plus can coordinate with the Cl minus of this one. Okay, so this anionic and cationic combination will be formed that. So once you treated with the cuprous chloride, now what will happen? This particular N2 group, it is a very strong in nature. I mean, it is a eliminate in the form of N2 gas. So as a result, what will happen, that particular Cl minus, okay, it's attached with the halorine uh, halorine derivatives. So as a result, I got the chlorobenzene. So now, regarding this concept, I just showing the past year question of QT exams questions. So here I have the nitrobenzene. The first case, I have the nitrobenzene. The unknown of the reagent is treated with, so I got the aniline derivative. So aniline derivative, again I treated with the unknown reagent, I got the diazonium salt of chloride. The once I treated with the diazonium salt, it's a water molecule. Now I got the phenol. So now I want to guess that what is the correct reagent for the X and Y. So usually I have the nitrobenzene. In that particular nitrobenzene, if I treated with the reduction of that metal plus HCl, especially a tin plus HCl or iron plus HCl, okay, among this one, the tin HCl, it's a preferred one. So now what will happen, instead of this oxygen, I can add the hydrogen. So it is a 6 stoichiometry of the hydrogen atoms are, it can be replaced with the oxygen molecule. So as a result, the nitrobenzene, it's converted into the aniline derivative. Again, the aniline derivative, it's converted into what, diazonium salt. So how can you convert into the diazonium salt? That if you want to make the diazonium salt, means you want to add with the nitrous acid. So what is the formula for nitrous acid? It's a HNO2. From the HNO2, how it is react, it will form the reactant of the sodium nitrate plus HCl's are required. So now, what is the option? The option A is the correct one. Okay, thanks for watching.